Okay, so quick update. I've completed the NASA SBIR Ignite proposal. So this is pretty much everything that involves, audit information, proposal budget, slide deck, and white paper. Let me just run through the slide deck in this video. That'll probably be the most interesting one. So let's put that down here a little bit. So basically what the proposal is, it's a two-phase. So the first phase is focusing on the electric propulsion device itself and being, applicable to current EVA spacesuit designs and CubeSat launches. And then phase two will be focused primarily on the capacitor metal spacesuit and integrating that power architecture from phase one into it. So yeah, here it is. EVA spacesuit propulsion. So I want you to imagine having the ability to put on a suit and be able to fly into low Earth orbit. That's, viewing this beautiful image of Earth whenever you want. And you don't need to use rockets. It's all electric. So you can just recharge it and do it over and over again as often as you want. Imagine starting off your day on Earth, going up to the International Space Station or whatever space hotel exists, and then flying back down. How cool would that be? So that's what I'm talking about here. It's having an electric propulsion system capable of functioning both in Earth's atmosphere and the vacuum of space. What this does, it creates a drastically reduced cost to access low Earth orbit. So currently, it's millions of dollars to send payload up to the International Space Station. The cheapest company right now is SpaceX because they have a semi-reusable rocket, and it's about $60 million to send payload up there. So imagine turning that $60 million into thousands of dollars. All right, so our proposal focuses on the electric propulsion through asymmetric capacitors and pulsed high voltage. So that's the capability to function both in Earth's atmosphere and the vacuum of space. So phase one focuses on integrating an onboard power supply to the device, and this allows for the immediate use into current spacesuit designs and CubeSats into LEO. LEO is low Earth orbit. So the commercial potential, the market segment or total addressable market, also known as TAM, that's for EVA spacesuit propulsion, CubeSat launches, space tourism, affordable access to low Earth orbit, and in phase two, EVA spacesuits. So our target customers are going to be NASA, aerospace companies, space tourists, and space-related R&D companies that need to send up CubeSats. Our potential competitors are SpaceX because they're currently the leader and pretty much only one capable of affordable and reusable access to LEO. And then Rocket Lab and Blue Origin seem to be developing certain things, but with further development, they'll be pretty decent competitors to SpaceX. So our commercial intent and commercial development process. So we'll focus on creating this prototype through 3D metal printing and testing it rigorously. So the full development will create a fully functional flying electric propulsion device with an onboard power supply. And the electric propulsion is again through asymmetric capacitors with pulsed high voltage. A capacitor is like a battery, except it recharges and discharges energy much faster. And it, depending on the shape of the capacitor, if you send pulsed high voltage through it, it can actually create a lift force. And it's capable of functioning both in Earth's atmosphere and the vacuum of space. This allows for affordable and reusable access to low Earth orbit. So some of the risks involved is completing objectives in a specific time frame. We'll be trying to complete all the R&D efforts for this initial prototype within 6 months. So that means we'll have daily and weekly goals that will need to be executed for the printing and sintering process of the prototype, so we can allow enough time for accurate testing. And then as we do the testing, we want to leverage different geometry and metallurgy for the highest output potential. So we want to have the device work for hours at a time, so it can go up to low Earth orbit and back again. So the commercial capability and the market entrance. So upon successful completion of prototype and sufficient testing, there will be pre-order sales available to consumers. The deposits will fund for further developments and build out the manufacturing facilities. So basically, we have the functional prototype will offer pre-orders, and those pre-order deposits will fund further manufacturing efforts. So this is our first SBIR opportunity, and looking forward to it if NASA accepts us. So once again, the market opportunity is reliable and affordable access to low Earth orbit, because that's a priority both for NASA and the commercial sector. And having a viable, reusable platform will be the differentiating factor in determining success, as costs can be greatly reduced from millions of dollars to what it currently is now to launching for thousands of dollars for access. So the electric propulsion system developed in phase 1 can immediately be implemented into current systems, and then with phase 2 efforts, a custom EVA middle spacesuit will be developed. This propulsion can handle small CubeSat launches and integrate into current EVA space systems. Currently they're using cold gas thrusters, so this could easily replace that on weight savings and functional use time. So having an increased access to low Earth orbit at a reduced cost will allow more companies to run experiments, create new space tourism, and create advanced technologies to benefit humanity. So let's talk about intellectual property. That's usually a stigma, but what I've kind of seen, especially with Tesla when they open source all the patents, it broadens the landscape and allows more people to understand the technology and build on it. So that's what we'll be doing. We'll be live streaming the prototyping efforts, and any patents we file will be open sourced because science belongs to the people. We dream big, we work together. And NASA's mission statement is explores the unknown in air and space, innovates for the benefit of humanity, inspires the world through discovery, which I think perfectly aligns with this. So for assistance and mentoring, all work will be done through direct labor. Basically, 5 engineers will be building this out, and we'll be leveraging the resources from Virtual Foundry and Amazon.com. They will provide the equipment, the printing, filament, the printers, the filament makers, the kilns, those type of materials. So outside funding won't be needed for this specific project because after phase 1 and phase 2 efforts conclude, the further development and manufacturing will be funded through pre-order sales. So it can immediately start going into market through pre-order deposits, and then a few weeks to a few months later, they can receive their finished order. So the key personnel involved in this process is me, Ian. I've spent the last 3 years in extensive study of these electric propulsion capabilities and different technologies. I got a business degree at Furman. I've been spending the past several years developing lucid dreaming techniques because I learned that Nikola Tesla would use lucid dreaming to come up with his inventions and ideas. So to create breakthrough technologies, I knew I would have to master lucid dreaming. So I've spent this past several years mastering that ability. I've trained over 40 students how to lucid dream too, and have had a 100% success rate. I'm really happy about that. Our lead mechanical engineer is actually my grandfather, Ben. He received his master's degree in mechanical engineering. He actually worked on the Gemini space program, which was the precursor to the Apollo program. And he also did some of the earliest research on air-cooled turbine blades that were used for jets and later systems. And he also owns a patent for a wastewater purification system, which coincidentally could also be used in the EVA metal spacesuit if it's sized down. So that's just a fun coincidence. And then we'll have 3 3D printing engineers in the Memphis area. They need to have some college or completed college and a strong background in mechanical and electrical engineering, especially involving Tesla type technology, because this will involve Tesla coils, transformers, and so on. How we're going to do this, everything can be done in a standard office space because we'll be using off-the-shelf 3D printers and kilns that are already prefabricated and already made. All this can be purchased through Amazon.com and Virtual Foundry, and the entire process that we're going through for phase 1 can be also done for the metal spacesuit in phase 2. So that's it. Thank you for your time and consideration, and we look forward to working with you, NASA. If you end up choosing us, that would be very exciting. So yeah, that's pretty much it. It was about 14 different documents that I had to complete for this progress. Also the white paper, which is just like a technical deep dive into the specific technologies, past experiments, things like that. So at this point, in the electric propulsion journey, I've kind of reached like the final leg of it. I can't really go any further until I hear back from NASA, other than some registration things I might have to do. And I'll probably, if they choose me, I'll have to present in front of them. And then they said funding is in November, something like that. And currently it's mid to late August. It's August 20th. So that frees up a lot of my time back towards lucid dreaming and the lucid dreaming business. So I was trying to think what would be the best use of my time, other than keep creating content and helping new students lucid dream. So I thought I'd structure my day into really understanding organic growth, because my original thought process was I should just raise a seed round so I can hire 5 to 10 employees and have sufficient funding for paid ads. And I still think that's a good route, but on top of that, I think it's important to learn how to develop organic growth. So what I'm going to be doing is, what I've seen is the average successful channel posts 3 to 4 shorts if they're doing like TikTok, Instagram, YouTube shorts. And if you're doing long form videos, like one a day, like the daily vlog seems to be the best. So, but then I did some more research, and like the people who really blew up like early on in TikTok, like Charlie D'Amelio, people like that, who have tens to hundreds of millions of followers and like huge video views, they would actually post, anywhere from 10 to 15 videos per day, shorts. So that just goes along with, that work effort. If everyone else is doing 3 and you're doing 12, you're doing 4 times more. So I think a starting place, since now I have this extra free time until I do the NASA presentation, is I'll be experimenting with 11 vertical shorts, if I can, per day. And 1 long form video like this, but maybe more moving around, or maybe I'll just do it like this. So that's kind of my current plan, and then of course I'll continue to direct outreach for new clients, and also direct outreach for the seed funding. I think that's still a viable option, but if organic's successful, I might not even need that. But it's best to do both, and it's better to have it, not need it, than need it, not have it, kind of thing. So yeah, that's kind of my focus now, and I'll update you or I might make another long form video doing the outreach process for the seed funding. Maybe I'll do that. But yeah, I'll update on the progress, and yeah, see you future Ian. Oh, and if anyone's just watching this for the fun of it, please subscribe, comment down below, let me know what you thought of the proposal and this organic outreach. All right, thank you.